Okay, so this section 8.3 is all about basically using our accumulation functions, which means using integrals, defined integrals, so from a point to another point, and then in certain contexts. So you're either going to be given like a word problem and you have to evaluate a function, or you're going to be given, like on the multiple choice, you'll be given like a graph and you have to answer a question. It's basically all about integrals, accumulation, setting up your formula. But I think the hardest part in this section is being able to interpret what the integral is telling us, okay? So this first part here, we're just given some examples and we need to answer what the question is asking us. So example 1 says, we have a 10-week-old Basset Hound puppy, and he is gaining weight at this rate. Very specific there, pounds per week, where T is the puppy's age in weeks. At 10 weeks, the puppy initially weighed 14 pounds. So what is the expected weight of your new puppy going to be at the end of week 15? So we know that the puppy originally weighs 14 pounds. So he's already 14 pounds. Now we are going to find the accumulation of the weight that is added each week after week 10. Okay? So that means we're going to need to add the integral from week 10 to week 15 of this rate e to the 0.0125 t dt. So again, this piece right here is the accumulation of weight in between the weeks 10 to 15 because this is our rate. So we're accumulating that rate to find out what that's going to equal, okay? Now, this, I would just expect you to plug this in the calculator. And if you plug this in the calculator, I want you to double check you get the same thing, but you should get 19.846 pounds. This next one says we've got an electric monorail system that is slowing down at a rate of 2t plus 25 feet per second per second. What does feet per second tell you? Acceleration, very good. Okay. T is in time seconds. How many feet per second does the monorail slow down between t equals 1 and t equals 5? So feet per second tells me velocity. Very good. So if I am given a function of acceleration and I want to find the velocity, what am I going to need to do? Integrate it, right? If I integrate acceleration, I'm going to end up with velocity. So if I integrate my function 2t plus 25 between my time interval that I was given of 1 to 5, plug that in your calculator. You could also do this one by hand pretty easily. But if you plug this in on your calculator, you should get 124. What are my units going to be for velocity? Feet per second. Okay, this last one, I want you guys to go ahead and give it a shot. We've got numbers of liters of oil in a tank changing at this rate. R of t is equal to 0.26 t liters per minute. T is the time in minutes. Initially, the tank has 14 liters. Write an expression that can be used to find the amount of oil in the tank after 10 minutes. Okay? Still working? We are starting with that 14 liters, and I am integrating from 0 to 10 of my function r of t, 0.26 t. And if you plug that in, we end up getting 27 liters. Okay, in my opinion, I think this is the trickier page of things, just interpreting what the expression is telling us if we're given some sort of integral and we're given some sort of like meaning behind the scenario. So if you have questions, please let me know. But the first one says we are given a function w of t that gives the number of water bottles produced by a manufacturer at time t hours of any given day. So explain what this expression is telling us. So we've got the integral from 4 to 7 of w prime of t. So let's first remember, what happens if I take the integral of the derivative? What did I say?
You did 47.
Oh, I meant 4 to 8, sorry. What happens if I take the integral of a derivative?
You get the original?
I get the original function, right? So this is actually going to output w of t, and then we're going to evaluate that at 8 and 4, right? And we're going to subtract that value of w of 8 minus w of 4. So what does that tell us? What does that mean in terms of the problem that we're given? What is W of T?
Number of water bottles produced.
Number of water bottles produced. So this would be the number of water bottles produced at 8 hours. And then this is the number of water bottles produced at 4 hours. So we're going to subtract those, right, if we're taking the integral of those two things. So we're going to find out how much was produced in between the hours of 4 and 8. Okay? So number of water bottles produced during hours 4 and 8. Okay, you always want to make sure you include that time piece in there in addition to like what it's talking about. Okay. Okay, the next one we're talking about the amount of oil is being drained from your pickup truck at a decreasing rate of quarts per minute, where T is in the time in minutes. What does the expression below mean? So we're integrating from 3 to 4 of R of T, and that's equal to negative 0.5. Take like 30 seconds to a minute. Tell your neighbor what you think it means. If you're totally wrong, that's okay, but I want you to at least try. Wonderful. So exactly what Olivia said, or you can write it something like during or between 3 and 4 minutes, the oil is drained. Oh wait, I want to say the oil drained is 0.5 liters. Maybe the amount of oil drained, that sounds a little bit more English correct. But you get the idea. It's math. As long as you have the time, what it is, and then what's happening with that value, if you're given that value, that's all I care about. Questions on that one? Very good. All right, last one, same thing. Go ahead and talk to your neighbor about what you think example C is talking about, and how could you write it out as an expression. Okie dokes. So Kevin starts with $500 in his account. And after 12 months, the money grows to $2,400. Or if you want to be like, use these as 500s of dollars, you could say that, and then 2,400s of dollars, but it's not too terrible math there to do 500 and 2,400, right? Okay, so not terrible, but you just got to remember when you're doing an integral, you're accumulating whatever stuff or whatever rate is happening, okay? All right, another little flashback here. Example 5, we're going to do a trapezoidal sum. It says we're given a city bus is accelerating from 0 to 18 seconds. The data of A of t is recorded in the table. The velocity of the function at the beginning at time t equals 0 is 6 feet per second. So find the approximate velocity of t equals 18, or at t equals 18, using a trapezoidal sum. So let's first write the integral that we're actually evaluating. If I'm trying to find the velocity at time 18, that means I have my initial velocity of what we started with, so v of 0, and then I'm going to add that to my integral of 0 to 18 of my acceleration function, because when I integrate acceleration, I end up getting velocity, and all of that information is given to us in the table. So now we just have to find the trapezoidal sum using this table of values. And then what are we going to have to add to it? At the end, you'll just have to add 6 to it. So I've got 6 plus. Now, when I'm doing the trapezoidal sum, the nice thing is that all of my time intervals are a value of what? 3. So instead of multiplying by 3 every single time, we can just say, okay, it's for a trapezoid, we've got 1/2 times my height in between the bases is 3. And then your formula, remember you multiply by the sum of the base. So I've got 1 plus 4, that's going to give me 5 plus 4 and 6, which gives me 10. Add these things together. Be careful you don't add incorrectly. 16 and 19. Okay, so my velocity at time 18 minutes. If you plug all that in, I know you guys can use a calculator, you're going to end up getting 124.5. And we got to think, what are my units going to be if I'm finding velocity? In terms of feet per second. Okay, any questions on that? Really, again, not anything terribly new, but more so just kind of retouching on a few things and remembering what that stuff means. Okay. All right, the last page of this is an example FRQ question from an AP test from 2010. So we're going to go through that, give you some exposure to that kind of question, and talk about how to solve that. Okay. This question is about a zoo. Okay, so a zoo sponsored a one-day contest to name a new baby elephant. Zoo visitors were able to deposit their name entries into a special box between noon and 8 p.m. So that's time t equals 0, t equals 8. The number of entries of the box t hours after noon is modeled by our equation up here, or our table, sorry. E of t is in hundreds of entries, and then t is in hours. Okay, so technically at 2 hours in, how many entries are there? 400, right? 400 entries have been in there at time t equals 2, okay? So question A is asking us to use the data in the table to approximate the rate in hundreds of entries per hour at which entries were being deposited at time t equals 6. Show what has led us to our answer. So we want to find what is the rate at time t equals 6. So there's nothing about time t equals 6 up there. But it's asking about a rate also. So just at t equals 6, it's obviously going to be somewhere in between 13 and 21. But I'm looking at a rate. So what am I going to have to do with those values in my table?
Mean value?
Not exactly mean value, but we're going to think about if I graphed all these points on here, like 0, 0, 4, 2, 13, 5, all these values, and I have this curve, I'm trying to find the rate at time t equals 6. So I'm trying to find the slope of that line. What is the rate of that value? So if we're looking at time t equals 6, what we're technically doing is we're finding, why did it write so large there? We're finding the derivative of my function at time 6. We're going to approximate that with a formula because I'm not given a function, so I can't find the exact. But I do know that e of 7 is equal to 21, and e of 5 was equal to what? 13. Then I can divide that by 7 minus 5. So if I evaluate that, I get 21 minus 13 over 2. So I end up getting 4. So again, if we go back and read the question, it's asking us to approximate the rate in hundreds of entries per hour. That would have been another good key thing there. Hundreds of entries per hour. Here's my hundreds of entries per hour. I have to set up that formula there. So our answer would be 400 entries per hour. Okay. Example B says to use a trapezoidal sum with our 4 subintervals on our table to approximate the value of 1 over 8 times the integral of 0 to 8 e of t. We need to use correct units and then explain the meaning of 1 over 8. So this should look familiar, should look something like we did last class. What is the 1 over 8 integral thing here? What is this? average, right? It's the average value, or in this case, the average number of entries that we're going to find, okay, at that certain, well, in the interval from 0 to 8, right? So if we wrote this out, oops, doing our trapezoidal sum, I'm going to keep that 1/8 out in front. So I've got 1/8. And then if we look here, oh man, we don't have the same distance in between. So we are going to have to set up our trapezoids differently each time. But could I take the 1/2 out of everything? Yeah, let's take the 1/2 out. So when I take the 1/2 out, then on the inside, I'm just going to have the distance between my hours. So for the first one, that's 2. And then I'm going to multiply that by the sum of my bases. So that would be 2 times 4 for the first one. Then my next one, distance between 2 and 5 is 3 times the sum of my bases, 17. What's my next one going to be?
34.
Yep, 34 and then 2 also, right? So 2 times 34. And then 1 times 21, 23, that's going to add up together to give me 44. Okay, do we see where I got all those numbers from for trapezoidal sum? Wonderful. We can plug that all in. Again, I know you guys know how to use your calculator. If we do, we're going to get approximately 10.688. Now it's, again, 10.688 what? Entries, but specifically hundreds of entries. Okay, so that was answering the question, that was using the correct units, but now it says to explain what it means in terms of the context of the problem. So if we want to explain in terms of the context, we already said this is the average number, so we can say the average number of entries is 10.688 hundreds of entries. The English isn't great there, but we get the idea, yeah? And then I need one other thing in there. Not per hour, but what are we talking about? What range of hours are we looking at?
Over 8 hours?
Over 8 hours, from 0 to 8, right? From time t equals 0 to t equals 8 hours. So at 8 p.m., volunteers now are beginning to process the entries. They process the entries at a rate modeled by our function p of t, which is hundreds of entries per hour between the time interval 8 and 12. So according to this new model, how many entries have not yet been processed by midnight? Okay, have not yet been processed. So let's go back to the table here and look at time t equals 8. How many hundreds of entries were there at time t equals 8? 2,300, right? So originally they have 2,300 entries. Okay, they're only going to be able to process a certain amount per hour, right? They're not going to be able to process all of them right away. So I'm trying to figure out how many will not be processed by midnight. So I have originally 23, and I need to subtract how much I am processing by midnight. So I'm going to have 23 minus my integral. My hours are from 8 to 12. Of my function p of t. If I integrate this function, that tells me how much I've accumulated in that time frame from 8 to 12. So if I plug this whole thing into my calculator, we end up actually getting a nice number, 7. So 700 entries have not yet been processed by midnight. Last example here, part D of this question. According to part C, what time were the entries being processed most quickly, and justify your answer. So we're still looking at that same time interval of 8 to 12. So we're trying to figure out what time was it the most effective, or the quickest, right? So if we're given this function P of t is entries per hour, we're trying to figure out what the rate of that, how it's changing. So we need to take the derivative of this function. So P prime of t, not too terrible here, we can do that. 3t squared minus 60t plus 298. Okay, we're trying to figure out where does that equal 0. If we figure out where that equals 0, that gives us 2 points that we could possibly have a maximum at. And then if we also need to test 2 other points, what other 2 endpoints? I just said it. We need to also test the endpoints, right? To see if it's being quickest at those points as well. So we need to see, when does this equal 0? And then we also need to test our endpoints. Okay, so we're going to get 2 answers on our calculator for t. And then we're going to make a little t-chart here and figure out which one is the quickest. Okay. Oops. So the 2 values that you should have gotten were about 9.1835 or 10.8165. Did we get those 2 values? Either using polysmelt or the calculator or the graphing calculator and seeing where they're equal to 0. So we're going to test these 2 points, and we are also going to test our endpoints of 8 and 12. So I've got 8, I've got the 9.1835, 10.8165, and 12. And now I'm trying to figure out, I'm trying to maximize the P of t function, how fast they're processing those things. So I'm going to plug these values into not my derivative, but back into my P of t function right here. So a few ways you can do that. You could type that in your y1, and then, on your main screen you can type y1 and then just plug in your number here. That's one way to do it. Or you can literally just type this thing, plug it in every single time. Either way is fine with me. I'm going to go ahead and write up the answers you should get up here, and I'll let you try it out. Double check you get the same thing as me. I get 0, 5.088, 2.911, and 8 for those. So double check that you got the same values, at least for one of them up there. So that way we can move on and finish the answer. All right, the last part of this question to get full credit would be to justify what the heck it means that we just did. So which value of t are the entries being processed most quickly at time t equals 12? Ooh, t equals 12. Okay, so we're just going to write that out. At time t equals 12. Actually, I'll just say midnight. The entries were being processed quickest at 800 entries per hour. Okay, you have to have all kind of 3 of those pieces of information, like the time value, what it is, and then, the amount it is, and then what it is, if you want full credit on the AP test. Okay.